Okay.
Okay, hey everybody, it's the 17th of December, 2024. This is Aiken PBL live coding from Gimbalabs, Sedan Labs, and friends. Hinson and I have been building this course. Hinson is walk-in right now and listening in. He took the teaching ball last week to take us through module 102. You can find that video on the Gimbalabs YouTube, and we'll be adding it to this course soon. And we're going back and forth. So this week, it's my turn to take us through module 103. We're going to pick it up again on January 7th. Okay, so today is December 17th. We're not going to meet on December 24th and December 31st. So this is the last lecture of 2024, and we'll pick it up again on January 7th, 2025. But for today, we're going to finish up the 100 level modules by taking a look at mock transactions. This is going to tie together a few of the things that we've covered over the last few weeks. In the first module, we showed you just how to get up and running with Aiken. And I emphasized that we're going to be using testing, native testing inside of Aiken, instead of building transactions that are actually on a blockchain. You got to see some of those examples of tests. And then last week, Hinson took us through writing our first smart contract. And as we looked at these validators, we also saw that you can test those validators. So some of the ideas we look at today are going to build on things that you're already becoming familiar with. And what we're really going to focus on is this transaction type. Okay. Because validators only work in the context of on-chain transactions, it's really helpful to be able to mock up different kinds of transactions so that we can make sure our validators are going to do the things we thought they were going to do. And in the code base, you'll see there's this lesson 0, right? Just a kind of preview. And every time we add code examples, you should be able to find links to those examples. No server is currently available. GitHub is so busy building AI that we can't just look at some regular code. There it is. Okay. So this code example is right here, so you can follow along and you can find it in the Aiken PBL examples repository. More on that in just a second. And right here in the course, there's some highlights of the important stuff. In module 103, mock TX, you'll find this. Now, what's really nice about seeing this high-level view is it allows us to think about all of the different data that we might want to validate on in our validators. Because a transaction has all of these fields, I can refer to any of these in an Aiken validator. Here's a trivial example of that. This is not one that I use very often when I'm writing a smart contract, but for example, you can write a validator that only validates when the fee is above or below some certain number, right? Why can I do that? Because I can access a transaction inside of my validator. And once I access the transaction, I can access any of these fields: minting, inputs, outputs, references, redeemers and datums, transaction IDs, and then really exciting governance stuff, voting. Right? Excuse me. So over time, we're going to use all of that. But the point of today's lesson is just to give you some examples to get comfortable using mock transactions. So as we go into the lessons, And as we go into the examples, that's what we're going to look like. We're also going to write tests to make sure that we, just quit that. We're also going to write tests to show that you can use these mock transactions in your tests while you're writing your validators. But before we do that, I'm going to jump over to the example repo. This is linked from the course, and hopefully you already have it on your device. If you don't, just make sure to go back to the earlier lessons. In Module 101, we show you how to install the dependencies you need for Aiken and how to get this repo on your computer. We're going to be focused on Module 103 today. Here's that mock TX we were just looking at in the course with the same content right here. One thing that happened since we last met is that the example repo was updated. You could see right here, Hinson pushed some changes to the repo 10 hours ago. GitHub is slow this morning. I wonder what's going on. Okay, so we have some changes, and it impacts a whole bunch of different files. And so I just want to point out a couple things right here. First of all, in the aiken.toml file, you'll see that a couple of dependencies have been updated. The compiler dependency for Aiken was bumped from Aiken version 1.1.7 to 1.1.9. The Aiken standard library was bumped from 2.1 to 2.2. And the external dependencies, right? The vodka library from Sedan Labs was updated from 0.16 to 0.18. We need to make sure that A, we have these changes, and B, that we are ready to work within this. So let's go over here. You could do this from any terminal window. I'll just use the one that's integrated into VS Code. The first thing I'm going to do is just run git pull to make sure I have these latest changes. So you can see, okay, I just grabbed that Aiken toml file we were looking at. Great. But now I'm actually going to have a couple of conflicts here. On my computer, I'm still on Aiken version 1.1.7. I'm going to want to upgrade that. Once again, let's open up that toml file. Aiken.toml shows me which version of Aiken this project expects. And so if I try to run Aiken check right now, let's see what happens. Okay, I actually get an error. Well, it says it's a warning. The errors are something else, but the warning is right here. And it looks like it's optional. You may want to switch. I'm going to do that. I'm writing smart contracts. I want to really try to do everything right. Okay. But you'll get this warning right here. I think this is something that everybody's going to see over time, right? Because Aiken is always being updated. And I just want you to have this in your head that it's pretty normal to have to bump your compiler version and update Aiken. So I need to update, and I'm going off screen right here. I forget which installation method I used on this computer. I think I actually used, I think I built it with Cargo. So that's what I'm going to do. All right, so you know from the Aiken installation instructions right here, we showed you how to install just with npm. Scott posted some details in the Gimbalabs Discord reviewing how to first install AkeUp and then use that to make sure you have the latest Aiken. It sounds like that was important on a Mac. So keep that in mind, and we'll update the course as needed. But you don't have to use any of these particular methods, whatever ones work best for you. And I happen to have Cargo installed on this computer. So I'm just in the habit of using this method. and that's what I'm going to do. So going back to my console over here, I can run this command from anywhere. I have a habit of just doing it from my root directory, so that's what I'll do. And let's just confirm that this works. Sometimes this won't work because sometimes Rust and the cargo tool chain is also updated. So for example, if you choose to go this route, and you do run into an error that's hard to understand, sometimes it's not clear why it's happening. Um, just make sure that you have the latest tool chain, and that goes for NPM or cargo or whatever.
And Henson's got a text in here. He says, my way of doing Aiken update is usually go with the command which Aiken and see where we originally installed Aiken and then use the same to update the version.
Yeah, good. I'll show you that too as soon as this finishes building.
How is everyone? I mean, I'm curious about what everyone thinks is like this stuff that you're like, oh yeah, this is obvious. You do this, or are you like, ooh, like me, this is kind of interesting because this is so fundamental to working to being a contributor, and it's weird what you learn. You know, you're like, oh, I didn't even realize that that was something to learn. You know, um, I'm curious
So we can
as
see that it was successful here. And if I run which Aiken, we should see that it points to this path right here that was just replaced. And we do. Right? And so yeah, if I wasn't sure, then I could run this first and I would see, oh yeah, okay, I have the cargo in my cargo. That means I used Rust and cargo to install this the first time.
ah.
Yep, and Faizan says Aiken clean and Akup clean and Akup works. Akup is basically that's your utility for managing your Aiken installation. Very helpful.
Okay, okay. Scott puts in ACUP list and then ACUP install the exact version.
And you can see on my
Uh,
computer, I didn't even install Akup because I went directly this route. Akup is installed via also a variety of methods. You can install it with npm, homebrew, direct from their download URL, and then you can use that. But you can see that ACUP itself is optional, um, just shared as a convenience.
oh, nice. ACUP clean removed two different versions. I guess that's good. And ACUP list, I guess, will just tell you all the ones that you've got installed and maybe even where they're installed. Oh, ACUP list.
All right. I'm going to run Aiken check again. And this time, what you'll see is I no longer get that warning about my version of Aiken because now I'm up to date. All right. So hopefully that little, yeah, this is a realistic detour. Everybody is going to confront this at some point, and it is worth it to make sure that you're up to date. Now, there's one exception to that. If you build some validators with Aiken and you're already using them in production, that means that you used a particular version of Aiken to compile your code and to generate an on-chain validator address. And if you ever want to be able to recreate that address, sometimes you won't get the same one after you move to a different version of the compiler. That's why it's worth it, right? Right now, we're just testing. We're not deploying any of these things on chain, so we're not too worried about making sure that our validator addresses or policy IDs derived from our Aiken code need to be consistent. But of course, once you have an application on mainnet, you really want to make sure that you can generate those on-chain artifacts exactly as they were before. And that's why once you're in production, knowing which version of the compiler you used and having access to that version of Aiken is going to be really important. Does that make sense or raise any questions for anybody? Okay. So now I know I'm up to date and we can move ahead. I'm going to zoom in on the terminal and come back to it in just a moment. And I'm going to switch back over to our introduction right here. So first, let's run this test right here, just to see what response we get, okay? So I'm going to run Aiken check -m, and then the name of this test right here. Aiken check -m, and this guy. And I shouldn't have those parentheses there. There we go. All right. So the test passed, but what just passed? Let's go look at it. So now I'm going to open up this L0 once again, and I'm looking for this line right here, M103 L0 Aiken, built-in placeholder. Okay, there it is, lines 33 to 35. What is this checking? Well, it's checking whether or not transaction placeholder and placeholder are the same thing. But what are those? Sure, the test looks like it passed, so we feel good about that. But what really are we testing here? Let's go find each of these variables. Transaction placeholder. Ah, that's defined on line 12 by hand. This is just a line by line copy of what a transaction is, just so you can see it. As I mentioned at the start of this lesson, I just want you to be able to sit back and imagine the ways that you might use these different transaction fields to create some incredible on-chain logic. But we didn't really have to do this. Why? Well, this thing that we wrote by hand in our code is actually the same as this other thing called placeholder. Where's placeholder coming from? I'm going to scroll up all the way to the imports. And on line 4, you can see that we're importing from Cardano/transaction, which is one of the core Aiken libraries. And it provides a couple of types that we're going to use: output, reference, and transaction. And then, aha, it provides placeholder. And we're going to go look for this in the documentation in just a second. But for this moment, just notice that, okay, this placeholder thing that I can import from here is the same as what we wrote by hand. And what does that mean? Oh, it means I never have to write all of this by hand and give it a name transaction placeholder. It's just built in to Aiken, as the name of this test suggests. Any questions about that bit? So now we have this tool called placeholder. That's really helpful. Let's take a look at the documentation and see if we can find, what was that? Where were we importing from? Cardano/transaction. In the documentation, can I find that? Well, here's Cardano right here. And then I see /transaction right here. That looks promising. And if I go into these details, I could scroll or I could just search placeholder. There it is. placeholder is just down below on this page, Cardano transaction. And what is it? Placeholder. It's a empty transaction to serve as a base in a transaction builder, particularly useful for constructing test transactions. Ooh, that's what we came here to do today. Very nice. Every field is either empty or null. And in particular, there's this zero transaction ID. A transaction ID has to be a string of this length, right? But we're just populating with all zeros. And then, for example, validity range is interval everything. Can we confirm that over here? Yes, we can. The ID of this transaction, there's that string of zeros. How many are there? 64. Okay. And the validity range, yep, it says interval dot everything. Most of these other field values are self-explanatory. An empty list is just some open and closing brackets with nothing inside. Zero is zero. Ooh, this one's kind of interesting. Okay, assets dot zero. Keep that in mind. That looks a little bit similar to interval dot everything. And then for datums, we have this dict dot empty thing. And we'll get to that. We'll look at that, right? But for the most part, we just have all of these empty or null values to work with. Great. There were a couple other tests here. This one, once again, tests for equivalency with placeholder. Now we're familiar with that, but it's checking to see that placeholder is equivalent to this TX. And TX was defined right here. Ooh, where's that coming from? This says, let TX be mocktail TX. And then this right here, this is actually not helpful. I got to figure out, is that prettier doing that? So this triangle symbol right here is a bar. On my US keyboard, this bar right here is above the carriage return on the right-hand side, right? These are often used like in JavaScript. A double bar is the OR operator, if you're familiar with that. And then it's a like a pointer or a greater than sign, right? And so if you put a bar and a greater than sign, this is the it's not a triangle operator, it's just my VS Code is formatting it like that. Okay, so if you ever see that triangle, that's what it is. And it won't look like that when we copy and paste these things into the lesson content. Sorry about that. I forgot that was the case. All right, so what are we doing? And we'll talk about this function or this function operator right here. What you can see is that we're taking a function and then we're applying to another one right here. And we'll get to the actual usage of that. But for now, let's see where mocktail transaction is coming from. Mocktail TX. And there's complete right there. So these are helper functions that we are importing from the external library, not directly from Aiken, but from Mocktail. And we're using both of them right here. And we're showing that if you want to create a Mocktail TX and then complete it, that will give you the same thing as a placeholder. We're also doing a quick check on some validator, and this is really the meat of today's lesson. So this is the always succeeds validator that we looked at last week with one twist. This always succeeds validator combines two of the things you learned about last week, minting and spending. And this is showing us that both of those endpoints can be included in the same validator. I think Hinson mentioned this last week, and a lot of you are probably noticing already that this pattern is possible It's part of assignment 102 to explore this a little bit. But just in case um, you haven't seen this yet, I want to make sure that everybody understands, right? Inside of a validator, I can write a different endpoint for a variety of different script types. And ultimately, this becomes really useful because often you're going to be reusing logic. And you might be able to imagine building an application that mints tokens when certain spending conditions are met, or allows you to spend tokens when certain minting conditions are met. And keeping all of that logic dependent on each other can be a really helpful thing. For anything other than minting or spending, this validator fails for all other script purposes. But we have a pretty typical always succeeds spend and always succeeds mint right here. So we're going to test a few of those things. Look, here's the mint endpoint, always succeeds dot mint. And here's the spend endpoint, always succeeds dot spend. And we're passing variables to this one just like we did last week, except with this placeholder transaction, which is, this is the imported one, right? But you could have used any of them, right? We could replace that with this transaction placeholder, or even with the mocktail transaction right here, and any of these tests will work out. In the spending one, we also define a mock input. Here's a transaction ID, right? And an index. And we just want to make sure that this test will pass. Similarly, right, a UTXO ref, similar idea right here. And we can check that. Well, actually, no, I'm getting ahead of myself. Let's come back to this one in just a second and make sure to run these two tests first. Hey, Hinson.
Hey,
So I'm going to run Aiken check, check. Aiken check dash M on this one, minting policy. And we can see that that works. Okay. And I'm going to run the same thing, Aiken check dash M for this one. And what we're going to be doing in this course is little by little, we're going to start to assume that you know these steps. When you look at example code, look for the tests. And the expectation is that A, you'll run those tests, and B, maybe try to break them, right? And that's a really nice way to understand how things work. So we're going to get into breaking some tests in just a minute when we jump into some of the validator examples. But before I do that, let's just talk about what this is doing right here, right? So this guy, mocktail mock UTXO ref, what's it doing? It's checking that this is equal to all of this. Well, what's an output reference, first of all? Notice that what's not part of this, right? Um, Output reference is imported from Cardano transaction, just like transaction and placeholder were. And then mock UTXO ref is imported from mocktail. And this is showing you that there's two ways to build a mock output reference for testing. One, with the built-in Aiken output reference, I can always construct this thing. Or because I'm going to be using UTXO refs frequently, mocktail makes it even more convenient, right? Just less keystrokes to write it this way than to write out all of this. So this is provided as a convenience. And what the test shows us, Aiken, check dash M. What the test shows us is that these two things are equivalent to each other because, oh no, this one didn't pass because why? This needs to be all zeros. Oh, did that fail? Henson, did you expect this one to fail?
Um, Not really. Maybe yeah, I gotta check it.
This might be just a change, right? There's a few things going on when we upgrade libraries, both Aiken and dependencies, but it looks like I got a failed test because this mock UTXO ref. Oh, right. You preloaded a bunch of strings in to mocktail. And that's what this index is doing
Yep.
for us, right? It's just picking one of them. So it looks like maybe it picked the wrong one. It gave us this. So what I'm going to do is copy this guy, replace that, and then I'm going to run the test again. And that one passed. All right. So yeah, this is showing us that we can construct an output reference with some transaction ID that we get from somewhere, or Mocktail, if we look at the source code, just has a bunch of transaction IDs loaded in and ready to go. And the one at index 0 happens to be this string. If I change this to a 1, save that, and then run it again, I'm going to get an error again. Because look, at index 1, Mocktail has a different transaction ID loaded in. I'll copy that, replace it right here, save that, run the test again, and once again it passes. So there's a nice little example of breaking this test, reading the error, right? Errors are not a bad thing. This is actually meant to be a really helpful, legible error, right? It says I expected this to equal this. With my eyes, I can see that those don't match, and I can update my tests accordingly. Any questions about that guy? Pipe operator. Thanks, Scott. Okay, so that was a lot of preview stuff to actually get into the lessons. But when we finally get to lesson 102.1, hopefully a lot of that preview stuff is going to help us move pretty quickly through these examples. And the main thing I want you to start to establish as you work through these lessons is a pattern for how you go through the examples. We can open up some example code. We can review the code. We can notice things. And then we can try to write, test, and compile this validator. And once you know these steps, you're going to be able to reapply these steps to any example, whether it's an example you see in this course or just some other Aiken code that you find somewhere else, say in the Asteria repo, right? Or in any other open source Aiken repo. So we're going to go through these steps together a couple times with the expectation that this is really starting to become a pattern that you can apply over and over again. Now, in the code, we have these 5 files. We were just looking at mock TX, and we have 4 lessons, 1 lesson for each of these examples. So we're going to go through a mock spending transaction, a mock minting transaction, a locking transaction, and an unlocking transaction. We start with spending. And for this, oh, I'm sorry. I was still on. Yeah, I knew something was wrong there. Sorry. This is the lesson Hinson showed us last week. I'm supposed to be on 103.1. I knew something was weird there. Okay. But that's a helpful review because by the time you get to lesson 103.1, which is where now I have the right thing on my screen. By the time you get here, we're already going to be starting to assume that you're doing these things on your own. Okay. And what you'll see down here, right, is that we're following some similar steps each time. And yeah, this is what I really wanted to say to everybody. Before you start this lesson, make sure to read the intro. That's why I took so long to go through that intro and to give you all some background knowledge. Because that intro is really important and it allows us to jump in right here. Okay. So now what I'm going to do is I'm going to put on my screen this example, and I'm going to line by line go through some of these notes. But all of these notes are here for you to review in the lesson, and then we'll go through the step-by-step stuff at the end. So let's open up L1 and close the terminal for the moment and take this from the top. Now in the lesson notes, it says, start by looking at lines 43 to 48. Lines 43 to 48. Okay. Right here, we have a transaction. And you just saw that a transaction can have many different fields. In this case, we're not going to use all of them. The only ones that are relevant to the test we're going to run right now are the inputs, the outputs, and the fee. All of the other fields are just going to be those nullish or empty values. And that's why we have this little dot dot placeholder here. What does this do? This kind of fills out all of the values in the list that we don't really care about. Okay. I care about inputs, outputs, and fee. As for the other ones, just fill those in with empty values. Now up above, we need to define the input, and output that we're using right here, input and output. Notice that this list of inputs is a list of length 1 because input, as it's defined right here, is just a single input. And same thing for output. This is a list with exactly one output in it. There it is. What's in these inputs and outputs? Well, we could see a couple of things. We're using that mock UTXO ref that we just looked at in the previous example, just to give this input a transaction hash and an index, right? If this was a real on-chain transaction, of course, I'd want to be spending real UTXOs from the blockchain. This gives us the ability just to have one, right, with its transaction hash like you just saw. An input has that reference, transaction hash and index, and an output. That's what an input is, right? The input to any transaction is the output from some earlier transaction. That's why we call it UTXOs. Okay, what's the unspent transaction output that I'll be spending as input here? So one really important thing to notice is that this output has the same shape as this output. It's just that an input is an output with a reference. So we can now look at these side by side. For each of these, we need to define an address. At what address was that output being locked, right? Or in other words, who's going to spend that UTXO as an input? what's the value in the UTXO? Every UTXO must have Lovelace in it, and it can optionally have other tokens. This one just has 10 ADA, 10 million Lovelace. We're not worried about datum for now, and we're not worried about reference scripts for now, not in this UTXO or this UTXO. But it does matter whether or not this transaction will balance the Lovelace in its inputs and outputs. So look, will it? This transaction has an input of 10 ADA, an output of 9 ADA, and a fee of 1 ADA. The math works out. 1 plus 9 is 10. If those weren't balanced, this would not be a valid transaction. And we're going to try to break that in just a second. Okay. So then, okay, so payment credentials, we have from Mocktail, mock pub key hash. That's going to be imported from Mocktail, just like we already looked at mock UTXO ref. Now you can see that we're using, a whole bunch of other imports from Mocktail. One of them is mock pub key hash. And this one right here works in a similar way to how mock UTXO ref works. You can pass it a simple integer as an index, and under the hood, Hinson's drawing on a list. So what do you said in the chat? Quickly check source code, mock data generation. Yeah. So you're creating valid strings that we can then pull in and we can use them without having to, nobody wants to make up a policy ID off the top of their head.
Yep. So I just check there's maybe some change in the serialization logic. So the bytes might get a little bit different. So the hash itself, I use the Blake 2B to generate. So it will eventually be a little bit different. But usually when we come to the unit testing, it just doesn't matter. So yeah, just provide a little bit more context about why it breaks after the version bumping. Yeah.
Makes total sense. Yeah. And so this is a case where if I went back to Aiken 1.1.7 and I reinstalled Aiken 1.1.7 on my computer, that test probably wouldn't have broken, right? If I just went back to the earlier versions of everything.
Yep,
So if this
I
was
think so.
mission critical for me to get the same hash, I'd be able to recreate it. And that's a fun activity for outside of lesson time. And if anybody wants to try playing around with versions, you could do that with your weekend coffee. All right, so let's take a look at some tests here. The first thing we're doing is we just want to confirm whether or not what address is equal to mock pub key address 0. So we say let the address in input.output.address in input.output.address. Okay. Let's see if that is the same as the mock pub key address we get from index 0. And this is none for no staking credentials, right? Now, how does it know about input in the first place? Oh, okay. We say grab that mock spending transaction, right? Grab this mock spending transaction, get the input in the list of one, expect there to be a list with one input in it. And then we'll say that, okay, if that's there, we're gonna say that that's the input we're using. Okay, so if the inputs in the transaction have a list of 1, we expect that. We break the app if we don't get this, but assuming we do get this, we move forward with that input. Have we talked enough about the expect keyword? I can't remember if we really covered it in the first two sessions. And you'll be able to read about that in the course. But this is a really key idea here, right? Right here, we say let tx be a thing, right? I could say let num equal 5 plus 2 would be fine, right? Um, and that's all well and good. That gives me access to variables that can change and be reused in an application. But sometimes we want to insist that something will be true about a variable or else stop using the validator. And this is written up in the Aiken docs. We can go look at that for just a minute. This is going to be in the language tour, or you can just search for the word expect. Expect. Expect a special assignment that works like let, but allows you to perform potentially unsafe conversions. Okay. Now, you can go through all of this on your own, but this is the key thing right here. This may seem like bad practice, but remember, we're writing smart contracts, right? And complete error handling that I might expect from a regular application is sort of unnecessary. The goal of a validator is either to fail or succeed, right? And I'm not trying to cover every possible thing that could happen. I just want to make sure that my validator only works when it's supposed to work and never works when it doesn't. And so what we have is this ability to expect some variable, some pattern to match our expectations, right? And when it does, we're going to move forward. Oh, if the TX inputs have just one input, call that input input. This might help. We could just call it foo, right? Just what not foo. Whatever I'm writing right here is just the assignment that I'm giving it right here. What matters is if I get this variable, give it a name, and then let the program move forward. Okay. But what really matters is that if this was not the case, if there were two inputs, for example, everything would stop right here, and essentially we would say that's going to return false, right? The rest of the test is going to fail. So that's what I want to show you right now. First, let's run this test, make sure it works. And then let's try to make it not work. Okay. Aiken, check. I'm wondering if this one's going to pass or fail because of the same serialization thing from a minute ago. Let's find out. Nope, that one's fine. Okay. So we have that the address in that input is the same as mock pub key address at 0, which makes sense because we had mock pub key hash 0 right here, and those are related to each other. Great. What if I did this? What if I just passed 2 copies of input to this transaction? So now instead of being a list of a single input, inputs was a list of 2 inputs. Well, what's going to happen with this test? Crashed. Okay. So the key thing I want you to see here, yes, the program failed, and we get this message. It exited prematurely. That's really helpful. Where did it exit prematurely? Oh, at the expect statement, because that's what expect does, right? Expect says, yeah, I want this variable, but only if it looks like this. Oops, That one didn't look like that. It was input, input, fail, done. Can't even move forward with my validator. You're going to use the word expect frequently when you're writing validator code. And hopefully this little demo right here starts to give you a picture of how this works. Good. I'm glad that failed. Yeah. I don't want I don't want anything to work if this pattern is not matched. Any questions about that, or is anybody thinking of a different way to say this? I'm kind of trying to like guide you through a really important idea that I'm not great at explaining yet. So I'm just really hoping this example helps you build up a mental model for yourself. All right, I'm going to keep going, but please jump in and interrupt as questions come up. So this test right here is actually pretty similar. Mock output. What are we checking this time? Once again, this bit right here matches this bit. Okay. Get the transaction, match this pattern. If there's one input, look in that input for the output and confirm that the output matches this. And this should not be surprising right here. That's exactly what it says, right? We've got 10 million Lovelace in value. We've got mock pub key hash 0. That looks like it's going to match. Let's run it to make sure. We can check -m this test. And sure enough, that one passes. And this one runs both tests, you see, because speaking of pattern matching, it's running this check based on this pattern. Two of these tests have this pattern. There's that one, and there's the one with the _2 on the end. Let's just look at both of those side by side. This one is checking that our input matches this. The other one is checking that the output, look at this pattern, right? Very similar to right here, but this time we're just making sure there's one output in the list. And we want to make sure that that output is going to this other address and that it's getting this much. Of course, if in my mock transaction, I try to send 19 ADA instead, and I run this test again, of course, the second one is going to fail. First one, still A-OK. I didn't change that. But the second one, we got a nice big error. And it's taking us through the entire data object, right? So we expected to get this. Instead, we got this. And it's up to us to look for the difference. Was the difference there? No. Was it there? No. Was the difference here? Ah, yeah, that number doesn't match that number. Good, and I don't want that to pass. Very nice. And so finally, we can pull it all together. We can build a full transaction and we can try to figure out if Mocktail's version of building this transaction is the same as the kind of Aiken native way of building the transaction. And the question is, will mock spending TX, right? Will mock spending TX be equivalent to the mocktail TX defined right here? Aiken check -m. And let's do this one. Are these mock transactions equivalent? It looks like they are. Very nice. So why does that matter? Well, because everybody has their own taste as a developer. Do you want to build mock transactions this way using Mocktail? Or do you want to build them this way using kind of built-in Aiken patterns? There's no right answer. Whatever you prefer is better. But what I hope you can see is that Mocktail gives us a way to write the same object with less lines of code. So it's going to save you time once you start putting together tests very quickly. And that's one of the main reasons Mocktail was built. There's one more check down here. We're checking to see that the mock spending transaction, what was the difference? Oh, you're showing us that you can mix together, right? So I can define an input like this using Aiken patterns. I can define the output using mocktail patterns, and they can be mixed and matched, right? So this one is a mashup of both patterns, and that's fine too. So the message here is you don't have to pick one and religiously use it all the time. You have a flexible toolbox where you can pick the best tool for the job. Any questions about that bit? So we weren't yet really validating much. Like we pulled in, yeah, right here, we're only looking at transactions. Okay, so in this example, we're not even looking at a validator. And I think this is going to be a lot more fun once we are starting to do this in the context of actual transactions. So you can read lesson 103.1. It accompanies everything I'm showing you here. As always, if you have questions, you can use the chat at the bottom of the lesson. And when it comes to what we recommend that you should do, this is the pattern, right? We recommend at the very least, whenever you see a code example, always read the imports. Know where the tools you're using are coming from so you can find the documentation or the source code to learn more. Run the tests. If you see tests provided in a file like the one we were just looking at, run them. See what happens. If you're really feeling it, try to break those tests and understand what makes them work and not work. And then, as I just showed you, there's some equivalencies here, and it's helpful to know when, for example, um, mocktail TX and the placeholder TX are going to give us the same thing. So always try to look for those equivalencies in the tests. We're going to show you some other equivalencies as we move through the next few lessons. Any questions before we jump into the mock minting transaction? All right, we front loaded a lot in the intro and in the first lesson, but now you'll see that this example is pretty short. We're going to look at an example, but most of the work is on you to review the outputs, review the imports, run the tests, and look for equivalencies. And I'll demo each of these things right now on this example. But after moving pretty slowly through the intro in the first lesson, I'm going to move quickly through the next three examples. Minting transaction with a validator, locking transaction, and unlocking transaction. And actually, does this one even have a validator? No, this is just a minting transaction. Excellent. So we're not even talking about testing a validator yet in this example, just like in the spending example. But let's do these three things. So reviewing the imports, I can see that we're pulling from Cardano transaction, right? The Aiken library, transaction and placeholder, just like before. And now we're also pulling in this one from Cardano/assets, which you can also find in the Aiken docs. Cardano assets right here. And we're pulling from here a function called from asset. From asset. Construct a value from an asset identifier and a given quantity. So we're going to use that. And then we're importing several things from Mocktail once again. Add mint, complete mint, Mocktail, policy ID, Mocktail TX. Some of these I'm already familiar with. Others I might be seeing for the first time. We build a mock minting transaction using transaction from Aiken. And in this case, the only field that's not coming from the placeholder is the minting field. I want to mint an asset with a certain policy ID, a certain token name, and I want to mint one of them. Let's test whether this guy, mock minting TX, does indeed mint a policy ID. Mint a token with this policy ID, the same token name, and that it mints one of them, just to show that those are equivalent with each other. So step 1, review the imports. Step 2, run the tests. Aiken, check. This one. Oh, I forgot my dash M. Aiken check dash M. Try that again. There it is. All right, so what's equivalent here? That's the third thing we want to check. The minting field in this transaction in TX is the same thing as this. I didn't really need a test to be able to see that this right here is exactly the same as this right here. But this test confirms it. All right, so that's a pretty straightforward equivalency, but it's nice to see that our tests are working. So now let's go a little bit deeper and figure out whether or not this mock minting transaction is equivalent to some of the stuff we're importing from Aiken. So mock minting TX, mocktail TX builder. We're just testing whether or not this here, where we define a transaction using mocktail TX and we pass it the minting parameters like this, and we complete it, is this going to be equivalent to the way we built things up here? That's what this is going to test right here. Let's find out. Sure enough, those are equivalent. What could I try to break right here? Well, I could pick a different policy ID from the list. Let's try that. Oh, it didn't work. Very good. I wouldn't want it to. And what does it recognize as the difference? Right? Remember, once again, it's showing us the entire object it expected. It expected a transaction with all of this stuff. It got a transaction with all of this stuff. And without going through line by line, what I'm going to see here is that this policy ID is different from this policy ID because I threw a different index into mock policy ID. Okay? And that's how mock policy ID works. It's just giving you very quick access to a list of generated policy IDs, transaction hashes, addresses, signing keys, lots of stuff that you don't want to build for yourself. You now have access to in Mocktail, which is going to make it much easier to run realistic tests. Similar token name, mock token name 746573. That looks like it didn't change, so that looks good. And everything else is just nullish values, so we're not going to worry about those. One more test right here. Let's go back to 0. What does this one say? The mock minting TX. Okay, so this is just showing us that we can take, instead of constructing a mocktail TX, we can take the placeholder and just run this add mint method on it. And you can see that being imported right here. So just another way, right? Give me start with the placeholder, add this bit. Does that give me the same thing? Let's see. Ooh, that one broke. Nice. Why? 12F, 55C. Did I not? Oh, I didn't save. I didn't save after changing the 0 back to a 1. Let's see if this works this time. There we go. Now they work. Okay. So once again, what I'm really trying to model for you is a think aloud about how you might talk to yourself as you review code. Right? What are the imports? What are the tests? What equivalencies do I see? And then if you're feeling adventurous, can I break these tests and understand why they're breaking? Anybody have questions about this mock minting transaction? Just a simple mint of one token. And you can build from here with different quantities, different policy IDs, maybe even lists of token names. You can explore all of that. Oh, and here was our mock token name. So we did give it a name right here, and then it was converted to hex. Nice. So yeah, one thing you could do to play around is you could make a mock token name number 2. And then we could see if, why doesn't it like that? Oh, it's unused, right? That's why it doesn't like it. We could see, for example, we're going to get an error here if I make this a 2. And let's run that last test again. This time, the policy ID is not the problem. 12F49 matches 12F49, but the token name is different. That's the hex of test token name. But this down here, that's the hex of another name. You can see the string is a tiny bit shorter, and they both end with name. 6E, 61, 6D, 65, NAME. Look. 6E, 61, 6D, 65, right? So it's just a translation of each of these characters into its 2-digit hex code. Great. That's the mock minting transaction. And once again, the notes are here. The suggestions of what to try are here. And hopefully you can find some other creative ways to break the tests. Let's jump into actually playing with a validator. So now the reason we're really here is not just to write pretend spending and minting transactions. It's actually to write transactions that help us figure out if our validators are working as expected. So one example, just to start with, we might consider the transaction where tokens are locked at some validator address. And we want to confirm with this mock locking transaction that the right output is being locked at that address. Once again, you have the example. Once again, we suggest reviewing the imports, running the tests, looking for equivalencies, and breaking those tests. But a couple of just things to look at along the way. I want to touch on payment credentials, and I want to touch on mock datum as we look at this example. So I'm going to keep the live example on my screen, but I'll be referencing these notes as we go through this together. So here is the mock locking transaction. First thing I want to try to find is where are we locking this? Okay, so right here, when we build this transaction in the output, we are now not sending to a payment address. What we want to do is make sure that there is output to a script address. Where does script come from? Review the imports. Script comes from Cardano address. And in this case, we're importing address and script. Did we import anything from address in the previous examples? We did. In the first example, for example, we we imported address and verification key. Okay, address and verification key. Whereas over here, we imported address and script. Interesting. So let's go to the documentation again. Cardano, address. Yep, that makes sense. And I'm looking for, okay, I know I'm importing address in both cases. What's an address? It typically holds one or two credential references. It has to hold some payment credential. And optionally, a Cardano address can hold a staking credential, right? When you open up a browser wallet, anytime you're kind of generating a wallet in an application, those stake credentials are going to be provided for you with few exceptions, right? But when you're generating an address by yourself, you need both payment keys and staking keys, and the staking keys are optional. So if you've ever seen a short Cardano address and you're wondering, why is that address shorter than the one in my Nami wallet? That's why. It's a shorter address because it doesn't have stake credentials. So these payment credentials are interesting. In general, you've got this general type for on-chain credentials, and then we've got a few different kinds of credentials. A payment credential, a stake credential. But we also, if we keep going, what was I looking for over here? Script, address dot script, script. Where is that? I thought it would be right here. Looks like, I don't know if that was moved recently, but we'll find out if it breaks. I'm not seeing any errors here, so we're going to check this in just a second. But essentially the idea here is, I thought I was going to be able to show you side by side. But the idea right here is that a payment credential can either be a public key, like the one you hold in your wallet, or it could be derived as a validator. And when it's derived from a validator, we want to be able to say so. And that's why we're doing this right here. Instead of building an address that has a verification key as its payment credential, right? This would be like a wallet without staking keys. This example has a script as its payment credential, also with no staking keys. And what we want to do is we want to make sure that we can build a transaction that sends funds to a script address. And so as you work through these examples down below, running each of these tests, that's what you're going to see. This example actually looks very similar to lesson one, just with this change of scripts. Notice as well that we're not actually looking at the validator yet. And if you're familiar with any sort of on and off chain building, you might know this already. When I lock funds at a smart contract address, I'm not actually invoking the validator. Nothing prevents me from sending funds to someone else's validator, just like nothing prevents me from sending funds to somebody else's wallet. The rules apply when I want to unlock those funds. I can send 10 ADA to Hinson, but once I send it to him, he's got to be the one to spend it. And in the very same way, I can send 10 ADA to a smart contract address, but to unlock it, I got to follow the rules of the validator. The other critical difference here is that right now, because we're sending to a validator address, we probably want to consider datum. Now, I just said probably want to consider. 6 months ago, I would have said we have to consider it because it was not optional whether you were adding datum to a UTXO at a validator address. But with the most recent hard fork back in September, we upgraded to Plutus V3, and this for the first time gave us the ability to lock UTXOs at validator addresses without datum. It's a very, very exciting upgrade. But it's not automatic. What you saw in last week's lesson from Hinson is that we still have to define what to do when there is or isn't datum. And if we write a validator that expects datum, then, right, that there's that expect keyword again. If we write a validator that expects datum, then you're not going to be able to unlock UTXOs from there that don't have datum. So if you want to be able to use this new rule, right, where the datum is not required, you got to make sure that your validator is written in such a way that that's possible. So for now, I would recommend still assuming that when you send a UTXO to a validator address, it's going to have datum. It's worth it to assume that. Um, but just recognize that it's not exclusively the case. So this output right here, it's similar to the example in the first lesson, but we're sending it to a script address and we're including datum. And I'm going to leave it to you to play around with these tests. If people have questions, I think we'll pick up here on January 7th by like running through this example again. But if you've been here for this lesson today, or if you're watching this video later, I think you have enough to try lesson 3 on your own. Run each of these tests, figure out where the imports are coming from and what equivalencies there are, and then try to make some of these tests fail. Before we close, let's take a quick look at finally lesson 4. Finally, we're going to have a validator to talk about here. Let's look at it. Because when I unlock tokens from a validator, this is where the validation rules are going to matter. Where is it? Oh, this is just an unlocking trans. I forgot that this doesn't have. No, even here, we're not even showing you an example. We're just showing that it's possible to unlock from some validator address. But we're not even considering which validator it is. Right. Because in the next module, we're actually going to start playing around with datum, redeemer, and transaction context, which is going to give us this ability. So this one actually looks very similar to the previous example. Let's look at these side by side for just a minute. If I can zoom out enough so that you can still see it. This is lesson 4. And I want to also look at lesson 3 side by side. So right here, our locking transaction had an output to a script address with some datum, right? The unlocking transaction looks very similar. It's just that, oh, this time we're pulling an input from what appears to be the same address. It's generated from the same mock script hash, and it's got mock datum in it, which is defined like this. Yeah, this mock datum is the same. All right. So notice that these examples are very similar. Here we are showing how to lock a mock UTXO, and here we're showing how to unlock a very similar one. The biggest difference, when I look at the transaction that we're actually building, here I really only cared about the outputs. Here's a list of one output. But over here in this transaction, yeah, I'm concerned about the inputs, right? The opposite. But I also have to consider redeemer and datum when I'm unlocking from a transaction. Those are two of the fields in transaction, going back to where we started today, right? Here is our mock transaction. Of course, it has inputs, outputs. We saw a little bit of stuff with fee. We saw minting, but we also have datums and redeemers. Datum and redeemer are the primary place that you're going to create the arbitrary logic of your smart contracts. Of course, we can jump through all sorts of logic by just looking at what the inputs, outputs, fees, mint, etc. hold. But when it comes to writing your own custom business logic, a lot of that's going to happen in the ways you define your datums and redeemers, and then how you make those things talk to each other. So when we pick up this course in the new year, that's the next thing we're going to do. In Module 201, you're going to learn how to start using datum and redeemer for the first time. We're also going to look at some other things we have access to, like validator parameters, reference inputs, and then we're going to explore some of these parts of a transaction, signatures, validity intervals, and just checking numbers, different numbers of inputs and outputs. So we're going to pick up with Module 201. I imagine on January 7th, when we next meet, that we'll want to review these last two examples, Lesson 103.3 and 103.4 for just a minute. That'll give us a chance to warm up. Maybe we'll even run those tests at that time. And then we'll jump into the specifics of validation logic, like I just showed you in the code, right? Redeemer, datum, etc. down the list. So looking forward to this. We just did 3 sessions this month. This is our third. This will be on YouTube, and the first 2 will all be on the same playlist. If you're watching this video and you want to join us later, we meet for Aiken PBL live coding at 14:30 UTC on Tuesdays. We're not going to meet for the rest of December, but we're going to meet again on January 7th, 2025, and pick up right here. So thanks for hanging out. Long lectures to start. I'm looking forward to a day where I'm not talking the whole time, but y'all are asking questions and we're looking at your examples. But always when you start a course, there's some stuff to front load. I hope this has felt engaging, and I hope that people are feeling excited to kind of run through these examples on your own. And when you do, make sure to drop questions either here on Andamio or in the Gimbalabs Discord. That'll give us something to talk about for the next few weeks, even as live coding is not meeting. Any questions before we break?
Yeah, I just got need to maybe comment or rap about these things. I think it's reasonable that people ask few questions in this session, because just there are a lot of information about how these things works. But I just want to give a comment about writing smart contract or on-chain validator is that usually we want to test it really thoroughly. And that's why we spend in this lesson or module, we spend extensive time about how to build a transaction because this is really important about how you can test your validator before you actually start writing your validator. Because when you just directly write the validator without testing, it's just meaningless. Just you think that the validator will work and at some point, but you cannot kind of give a sufficiently high enough confident about it to use it for any application. So I would suggest everyone, if you really want to learn more about Icon and everything, just before our next live session, just try to run through the 103 again a bit and try to set up your own Icon workspace and test different way of building up the transaction and just get a feeling about how a transaction looks like and how you could manipulate it in the Icon syntax. It will help a lot in the later stage when you try to write the Icon code seriously for your depths. Yep, so that's a remark that I want to give it.
Here. And can you give that same recommendation every time we meet?
Yeah.
Good.
Vincent, I'm loving the vodka. I'm dropping the link in. Like these docs are great. And yeah, like using the mocktail and doing the tests and the primacy of the testing. And that's what the Aiken documentation, it's already baked in. It's in those like starting things. So that's wonderful. I'm glad that we're doing that here, following suit.
Yeah, they're a bit details that we really put in force about building the unit testing framework. There are actually three things. First thing is just at the time you try to build the transaction, it looks really close to the way we write off-chain code. This is the first part. Second part is after you complete build the transaction object itself, you can still manipulate it with the Aiken type itself, like the entire input, entire output, you just add them. There's also flexibility to chain after complete. The third thing is for every flag you put in using the mocktail things, the first parameter is always the condition that you could put in various condition about testing that. For example, you just add the signature when this test case want to asset. So the first variable is something like is signature added, something like that, so that you could dynamically assess your test case, dynamically building your transaction in different scenario very flexibly. So yeah, these three things make it kind of very powerful in my eye. And in our team's roadmap, we also want to build something like off-chain code generation out of the transaction kind of mod transaction because the flag is very close to the way we write off-chain code and we can map it really easily. But this is not coming anytime soon. Just we internally discussing. But yeah, hopefully everyone try it, enjoy it.
Love it. Thanks, man.
Thanks for building mocktail.
I know,
All right,
right?
everybody. We'll be around for Plutus live coding, more informal session tomorrow. Definitely more project based than this one, and open spaces to close out the year on Thursday. Have a
Love
good
it.
week, y'all.
Bye, y'all.
Bye.
Ciao.